Hi dear students, welcome to the next topic from electrostatics. Torque experienced by a dipole placed in a uniform electric field. This is one of the beautiful topics in electrostatics. A lot of concepts are there, and at the same time there are a lot of questions are coming from this area. So it's quite simple, and it's very interesting to learn about this. So first we will look into the heading. Okay, torque experienced by a dipole. Torque, I hope you have remember what you have learned about torque in your first year. Okay, so 3 places you have learned torque in first year. I don't know whether you have attended that sessions and you have learned that area. First time you have learned about torque in work power energy. Then another chapter is rotational motion, which is also called rotational dynamics. In rotational dynamics also you are learning about called torque. So torque you have learnt in rotational dynamics and in work power energy, and here also you are going to learn about torque. So totally in the entire physics, if you are taking both first year and second year physics, in 11th standard 2 places you have learned about torque. One is in work power energy, another is in rotational motion. Come to second year, 1 places, that is the first thing you are going to learn in electrostatics, and here you are going to learn about torque, and 1 places also you are going to learn about torque, that is in magnetism, magnetic effect of current. That area you are going to learn about the torque. Okay, so now we are going to learn the torque in electrostatics, but we need the information from other sides also. Whatever we have learned in from first year, that basic or the fundamental knowledge is required here also to attend certain kind of examples. We will see on the run. If you are not remembering also, no problem, we can learn it now. Okay, so let's start. So torque experienced by a dipole. This name you are very familiarized with, called dipole, in a uniform electric field. What is the meaning of uniform electric field? Uniform and non-uniform. Uniform means same strength. In school you have uniform, right? Because everybody will be equal. Okay, so uniform means all are same concept. So let's see what will happen. Heading itself, we are going to make it as a diagram. Torque experienced. Let's see what is. Dipole is placed in a uniform electric field. Dipole is placed in a uniform electric field. So let me draw the diagram first. So I have a uniform electric field. Like this I am drawing some lines. This is called what? Electric lines of force, or this is also called electric field lines. Okay, here we are going to place a dipole. Okay, so I have a minus q charge, I have a plus q charge, which are separated by a distance of 2L. Here we have something called dipole moment. And this blue color line is nothing but the electric field intensity or the field lines. So the electric field intensity and P is making an angle of theta. Okay, so what will happen? When a charged particle is placing in an electric field, it will experience force. What is that force? That is a electrostatic force will be here. F will be equal to QE. F equal to QE force. The direction of force is same as the direction of this electric field intensity. So the electric field intensities are directing from left to right. So E is from left to right. Of course, the force is also from left to right. Here also one force will be there. What is the value of that force? F will be equal to minus Q into E. So the direction of electric field is like this, and the force is also like this. So F is equal to minus Q is acting from left to right. I can also say F is equal to QE. Okay, F is a vector. If I am changing the direction of vector from one direction to another direction, I have to multiply it with one extra minus. So already minus QE will be there. If I am multiplying with one more minus, then what will happen? Then I have to change this arrow mark direction to the opposite side. So I changed the arrow mark direction. And now already one minus. If I am multiplying with one more minus, the direction is QE. Okay, something you have learned in your vector in first year also. Suppose if vector A is in this direction, then I can say minus vector A is in this direction, opposite to that of the same concept we are using here. F is equal to minus QE in this direction, then F is equal to plus QE in this direction. So this I am marking will be here F equal to QE. So that is one force. Now, what is called a torque? Torque means, a best example, you are opening the door and you are closing the door, right? There is a hinge will be there. So with respect to the hinge, the door wooden plate is moving in a to and fro way, like this, in a kind of rotational motion. So here also this is a dipole, and you are applying two forces will be there. What are the applying? You are applying the two forces. F is equal to QE like this, and F is equal to QE like this. So you can see I have placed two pens will be here. So what will happen? Two force will happen. This will rotate. Correct? Two forces will be here, two charges will be here. I am applying some forces, means somebody is pulling like this. Here also somebody is pulling like this. If both fields are pulling like this, means what will happen? It will come like this. Correct? So this kind of motion is called a torque. Torque means rotating effects. Our fan has rotational effects. So the charges are moving like a this way. So this will go up and this will go down. That is called a torque. So what is heading? Torque experiencing. Who is experiencing the torque will be here? The dipole is experiencing a torque. When it is experiencing a force, when dipole is placed in a uniform magnetic field, or a same magnetic field, if it is placed, it will experiences a torque. Okay, what will happen if it is placed in a non-uniform magnetic field? Uniform means same, non-uniform means different. What will happen? That we will see at the end of the chapter what will happen. But now we will concentrate on this one. Okay, so we know when a dipole is placed in a uniform magnetic field, it will experiences a torque. There are two forces are acting. F is equal to QE on right side and F is equal to QE on left side. Because of this one, this will rotate. Okay, so remember that. Okay, then we got to know. Next, we are going to calculate the equations for torque. What is the general equations for torque you have learned in work power energy first year? Force into perpendicular distance. I am just elaborating the perpendicular distance. What is a perpendicular? Perpendicular distance from axis of rotation. From axis of rotation to the point where force F, where force exists, to the point where force exists. Axis of rotation means the center point is the axis of rotation. This point is not moving, but both sides are moving like this. So distance from here to here, and that distance is a perpendicular distance. So F is equal to QE. So force is acting like this. So what is a perpendicular distance from the axis of rotation? So this dotted line is the axis of rotation. So the perpendicular distance means this distance. These sides we know total is 2L. So half of the distance is called L. This distance is L. As I told, adjacent side is called L cos theta. The side which is very nearer to theta is called cos theta. The opposite side is called L sin theta. So this will give rise to one torque. So I am writing tau 1 will be equal to force into perpendicular distance. In short, I will place it like this. Force into perpendicular distance. Okay. So force into perpendicular distance, which is equal to, force means what? Here first case QE into L sin theta. QE into L sin theta. This is the first torque. Now here also we have a torque, right? Here this is the force direction. So what is the perpendicular distance? 90 degree. We need something like this one. So here we are going to find this perpendicular distance. If this angle is theta, what about this angle? Opposite angles are equal as per mathematics. So thetas are equal. So the adjacent side, this is called cos theta side. This is called a sin theta side. So what this will come? L sin theta. So we have another torque is also there. Tau 2 will be equal to force into perpendicular distance from the axis of rotation to the point where force is applied. Perpendicular distance, not a slanting distance. So I need a perpendicular distance, means QE is a force, perpendicular distance is here also L sine theta. So I can say total torque will be equal to tau 1 plus tau 2, which is equal to QEL sine theta, QEL sine theta, 2 QEL sine theta. Okay, here I am introducing one term called dipole moment. You know what is dipole moment, right? 2LQ, distance between the dipole into any one charge. So 2LQ, so I can write these equations, 2LQ into electric field into sine theta. What is 2LQ is called? PE. So it's called PE sine theta. In short, torque will be equal to P cross E, or you can say PE sine theta. What is the direction of this torque? This will rotate like this. This will rotate like this. So its rotation is like this, which means what? This direction and this direction. This is what kind of directions I can say? It is a clockwise. This is a clockwise direction. So it's a clockwise. This is also clockwise, right? It is rotating in this form. So it is rotating like a clock. So clockwise direction of torque is experienced when a dipole is placed in a uniform magnetic field. Torque equal to P cross E. Or we can say PE sine theta. Theta is the angle between what? Dipole moment. Dipole moment from minus Q to plus Q, right? Dipole moment is acting from minus Q to plus Q. So this is the direction of P and this is the direction of electric field, and the angle between P and E is called theta. Okay. So torque equal to P cross E. So which is also called PE sine theta. This is the third torque you are going to learn in physics. Already two have learned. One is in work per energy, one is in rotational motions, and the third one is here, which is equal to torque equal to P cross E, which is equal to PE sine theta. Next, here in the next topics we are going to learn about there are some special cases are there. Special cases are available with respect to this studies what we have learned with respect to torque. So we will write some special cases. So I will remove this one. You can pause the video and you can complete your notes perfectly. Okay, so I need only the formula. Okay, so torque equal to P cross E, which is called PE sine theta. Next one, we are going to learn about some special cases. So we will write special cases. Okay, case number 1. Sir, can you tell me what is case number 1? Case number 1 is simple. Case number 1 is two conditions: theta equal to 90 degree or theta equal to 270 degree cases. Which means what? We have two cases, theta equal to 90 degree. So let me go with theta equal to 90 degree. Theta equal to 90 degree means what? Electric field like this. Dipole is placed 90 degree. So dipole is like this. Dipole moment is like this. Positive y and positive x. So always we are measuring, remember one point, always we are measuring the angle from positive side, not towards negative side, positive side. We are measuring the angle like this. What is this angle called? 90 degree. So if dipole moment is like this, one means minus q charge here and plus q charge will be here. If you have placed like this one, okay, dipole moment is like this, electric field will be like this. What is the equation for torque? Torque equal to PE sine theta. Theta equal to, theta is angle between P and E. What's the angle will be here? 90. Sine 90 means 1. So answer is PE sine 90, which is equal to PE. Maximum torque will get it. Okay. The another case is theta equal to 270 degree. When theta equal to 270 degree, what will happen? Electric fields are like this. No change to electric field. But dipole moment is like this. Opposite, just opposite dipole moment. So to have here minus q will come and here plus q will come. In that case, the angle, I'll make it with another color. In this case, the angle will be starting from here and going to this other side. This total angle is equal to 270 degree. So in this case, what is a torque? Torque will be equal to PE into sine of 270 degree, which means what? What is sine 270 value? -1. Mathematics, if not remember, please remember, sine 270 is minus PE. Here it is PE, here it is minus P. What's the difference? PE means F is equal to QE. Correct? Here it is PE I got, here is equal to minus P. One case torque is positive, another case torque is negative. Torque is a scalar quantity or a vector quantity? Perfectly, it's a vector quantity. So torque is positive and torque is negative means what? One case torque is in, if torque is positive means it is a clockwise rotation. In this case, plus Q will be here. It will act one force like this. QE will force. Minus QE will act a force like this one. So what will happen? Again, as I told in the first case, it will rotate two forces. One force will be like this. Another force will be like this. So what will happen? It will rotate like this one. This is what kind of motion? This is a clockwise rotation. Next one, minus QE will be here, plus QE will be here. Here one force, minus QE is in this direction and plus QE will act, QE force will be like this one. So what will happen in this case? Here one force like this, here another force will be like this. So which will rotate in opposite direction, like this. This is what direction, sir? This is direction clockwise and this is in anti-clockwise direction. That's what torque positive, torque negative. Torque is a vector quantity. Positive means clockwise, negative means anti-clockwise directions. So in this case, it will rotate like this. In this case, it will rotate like this. So here it is like this and here it is like this. So the directions are opposite. That's what we got different sign conventions for this one. Hope you understood, right? Okay, so that is a concept will be here for theta equal to 90 degree and theta equal to 270 degree. We'll move to the next one. Theta equal to 270 and theta will be equal to 90 degree cases we have seen. So we'll move to the next case. So let me write case number 2. In case number 2, we are going to learn about two cases. Theta equal to 0 degree and theta will be equal to 180 degree. Here I have to explain something extra. Okay, here I have to explain something extra. Theta equal to 0 degree cases and theta equal to 180 degree. So theta equal to 90, theta equal to 270. I hope you understood. Pause the video and complete your notebooks. We will go to case number 2. So I need little more spaces. So I will write it the complete board space I required. So I will write it theta equal to case 2 cases, theta equal to 0 degree and theta equal to 180 degree. We'll say first cases theta equal to 0 degree, which means that electric field like this. Okay, electric field like this, dipole moment P. So minus Q placed here and plus Q is placed here. P is like this, E is like this. P and E in the same direction, which means angle between P and E will be equal to how much? 0 degree. In this case, torque will be equal to how much? PE sine of angle between P and E. What is the angle between P and E? 0 degree. So sine 0. Answer is 0, which means no torque. So if you look into will be here, you can see minus Q will exert one force will be like this one. This is called what? QE force. Plus Q will exert one force in this direction, QE. This means that with respect to dipole, two people are coming and exerting equal forces in opposite direction. This guy is pulling like this. This guy is pulling like this. Both are pulling. Equal force. They are pulling with equal force. If they are pulling with the equal force, any motion will happen. What is the value of total force? Total force equal to 0, because two forces which are applying in opposite direction. So total force equal to 0 in all the cases. Whatever we have learned, case 1, case 2 and first torque case, everywhere force equal to 0. But torque is Torque is may or may not 0. Torque in theta equal to 90 degree cases, theta equal to 270 degree cases, we got torque is equal to PE. We got torque is equal to minus PE. But here we got torque is equal to 0. So in a uniform magnetic field, important point, in a uniform magnetic field, torque may or may not be 0. But force is always 0. That's important point. So here two forces are pulling like this. It is like stretching like this one. Okay. So this is one condition in physics. And here I can say the dipole is exist in stable equilibrium. This is important. The dipole is in stable equilibrium. Dipole is in stable equilibrium. Dipole is in stable equilibrium means what? Stable equilibrium in physics. Listen to the definition. I don't know whether you have learned it in first year or second year. I don't know. Second year anyway I have not taken. So first year I don't know whether you have learned it or not. Equilibrium means, listen very carefully, equilibrium means if we are disturbing the position of this dipole, after disturbance is removed, it will come back to the original position. If you are disturbing the system, after the disturbance removed, it will come back to the original position. That's the meaning. What is the original position of this one? Here minus q and plus q will be like this one. So let's make some disturbance and we'll see whether it will have stable equilibrium. So let me take this one. This is my electric field. This is my electric field lines. This is my electric field lines. Okay. So dipole is initially placed like this one. Now I am trying to change it like this, which means slightly I am changing minus q and plus q. I changed it. What is the direction of the initial position of dipole? Initial position of the dipole is like this. This I am going to draw in a blue color. Okay, blue color. This is the initial position. So this blue color is the initial position of the dipole. Minus will be here, plus will be here. Now I just change it like this one, which means I rotated the dipole like this. I rotated. Myself will be given some force and I have rotated like this one. So what is the definition of stable equilibrium? If you are giving any disturbance, yes, here I have given a disturbance. Then what will happen? Once the disturbance is removed, once I removed my forces, what will happen? It will come back to the original position. It will come back to the original position. Which means that what? It will come back to the original position means after I am keeping like this, I removed my hand or I removed the force. So what will happen? Here there is a two force exist, right? F is equal to QE force and this is F is equal to QE force. Because of these two forces exist in the system, what will happen? This will move like it will move like this one, which means that what? This will retain or this will come back to the original position. If it is come back to the original position, then it is called stable equilibrium. Okay, if you are placing in any direction also, always it will come back to the normal. So now you placed like this, it because of the electric field it is moving like this one. If you are placed like this, because of electric field it will move like this. So if you are changing to any position also, no problem, it will come back to this original state. If the system can come back to the original state, then it is called stable equilibrium. We'll see the next case, theta equal to 180 degree, our second case. This is our first case. Theta equal to 180 degree means what? P and E are in same direction or opposite direction. 180 means always opposite. So are in opposite direction. Suppose this is my electric field. Okay, this is my electric field. I placed a dipole in opposite. So dipole means minus q here and plus q will be here. Then only dipole moment in this direction. So P is from right to left and E is from left to right. Are in opposite direction. Are in opposite direction. In this case, what will happen to the value of torque? Torque will be equal to PE into sine of 180 degree. In this case, what is the value of torque? Torque will be equal to 0. No torque will happen. But similar to this one, this is what kind of equilibrium, stable or unstable? Okay, two types of equilibriums are there, stable and unstable. This is called unstable equilibrium. Unstable equilibrium. Unstable equilibrium. You know what is called stable equilibrium. Stable equilibrium means if you have given any disturbance, after removal of the disturbance it will come back to the original position. But in case of unstable equilibrium, if you have given any disturbance, it will never come back to the original positions. We will analyze the forces will be there. F is equal to minus QE is a force acting in this direction. So F is equal to QE force will be in the opposite direction. F is equal to minus QE in the direction. So F is equal to QE in this direction for this charge. For this charge, F is equal to QE. It is positive. So same direction. F is equal to QE. So what will happen? Two forces are exist and both are punching like this. Two forces are coming like this. Two forces are coming like this one. So both are pushing me. Both are pushing me means I am in a tight situations, right? The same thing will be here. QE force and QE force will be there. So both are pushing with the equal force. So I am in a crushed situations like this. So QE and QE forces are like this one. So here I call unstable equilibrium. Why I call this as an unstable equilibrium? Because if you have created any disturbance, what will happen to the disturbance? If you have done any disturbance in stable equilibrium, it will come back to the original position. In case of unstable equilibrium, it will never come back to the original positions. We will see it. Okay, the unstable equilibrium positions we will say. Now I am assuming I am just turning this towards right. So I'll just draw the diagram. Electric field like this and electric field lines are like this. Okay, I'm just creating some disturbance. I'm just placing. So plus Q here and minus Q here. I just tilted like this. What is the initial position? Initial position, my plus Q here and here minus Q. This dotted lines are the initial positions. Now the red color, whatever I'm going to mark it here, I'll use red color. So this is the final positions. So plus Q minus, so this plus Q is rotated and this minus Q is also rotated like this. Is rotated like this. So maybe let me make it the diagram bit more clear. So plus Q and minus Q, and now this plus Q initially like this, now it is rotated like this. So this minus Q will move to top and the plus Q will move to down. What will happen? Now this red color is the final position which will act to two forces. What will happen? One force is minus QE force in this direction. So plus QE force in this direction. Here also Q. So it is positive. Positive means same direction. So QE. See, if I am giving initial position is like this, minus and plus like this. If I am giving small disturbance, it is come like this one. Then after that what happened? I removed my hand. I removed my force. What will happen? Because of the force exist in the system. Because of the force exist in the system, these two bodies are acted with the QE like this and QE like this. So what will happen? Initially it is like this. So initially it is like this. So two forces are strictly acting like this. One. Next after that I have given a disturbance. Now the dipole is like this. Then I removed my hand. I am not giving any external force. What will happen? Because of the force exists due to the electric field, one force like this and one force like this. So this will just rotate like which means it is not coming back to this position. It is just going away from the position. If it is not able to come back to the initial position and it is not came back to the initial position where it is standing, if it can't come back, then it is called an unstable equilibrium. Okay, so there are two things will be there. Stable equilibrium means if you have given any disturbance, after removal of the disturbance, because of the force exists there, it can come back to the initial position, then it is called stable equilibrium. In another case, if you have given any disturbance but it's not able to come back to the initial position, then it is called unstable equilibrium. So in theta equal to 0 is a good example of a stable equilibrium, and theta equal to 180 degree is a best example of an unstable equilibrium. Theta equal to 90 degree, maximum torque will be there. Angle between P and E equal to 90 degree, our case number 1. Theta equal to 270 degree, angle between P and E is 270 degree, which means we got torque is equal to minus PE, which means what? Anti-clockwise rotation of clockwise. The torque is acting in anti-clockwise direction. When theta equal to PE will come in sine 90 will come. So in case of 90 degree, we have a clockwise rotations. This is all about the special cases. Next, we have to see some examples and as well as some special cases which are related with torque. We'll move to the next topic based on what we have learned about some theory. We're going to do some example questions based on torque. Okay. So here my aim is to get you to remember, get you to recollect what you have learned from first year also. Let me go to little bit of first year topic, then I will come back to here, which will be helpful for you to learn about more about to solve this equations and questions. There are two places we have learned in torque in your 11th physics. Okay, two places you have already learned. One is in your work power energy topic, where you have learned force equal to perpendicular distance. I already told what is the perpendicular distance. Perpendicular distance is the distance between the force and from the axis of rotation. So in short, I have written force into perpendicular distance. Second torque you have learned on your rotational dynamics, rotational motion. There you have learned one torque, and that torque will be equal to I into alpha. Alpha is called angular acceleration. Angular acceleration means the acceleration in a rotational motion. I is called moment of inertia. Different objects will have different moment of inertia values are there. Okay, so remember these are the two talks we have already learned in your first year. We'll come back to our example number 1. We'll move to our first example. We have an electric field. We placed a dipole minus Q plus Q is like this. We placed a dipole, and the angle between the dipole moment and electric field will be equal to theta equal to 30 degree. Dipole moment. Okay, and theta equal to 30 degree, and the distance between the dipole is 1 meter, and this is a point charge. Okay, point charge is given, and this is just a point charges, and the distance between them is 1 meter, and the angle between electric field and the dipole moment is 30 degree. Okay, in this case, if we have releasing the system, okay, in this case, if I am just let it down, at what angular acceleration the dipole will rotate, which means what is the speed in which the dipole is rotating. Question is very simple, which means I want to find out the value of alpha. That is a question. We can solve this one. We already know the equation of torque in electrostatics. So which is called PE sine theta. This is a rotational motion. So I can use any one of the equations. The first equation is a very generic equation. Second equation only will contain alpha. So I can equate with I alpha. P is called dipole moment. Its value is 2LQ. And electric field value is E. Sin theta will be given, which is equal to 30 degrees. Sin 30 means how much? 1 by 2. I is called the moment of inertia of this dipole. Moment of inertia of this dipole with respect to the axis of rotation. Suppose I am assuming this will have a charge M, this will have a charge M. This definitely it will give it to you in the question paper itself. Either they will give you the moment of inertia value, or they will just say the value equal to M, or instead of M they will give you some value. So here I am taking M. So what is the general equation of the moment of inertia? General equation of moment of inertia is equal to I is equal to mr square. M is the mass of the object. This we have learned in first year also. R is called distance from this body to the center position. Center position. So what is the from this body to center position? What is the distance? Total is 2L. So half of the distance is L. So we are going to substitute these values will be here. So there are two bodies. First body ml square. Second body plus q charge and minus q charge, ml square and ml square, and alpha. We need to find out the value of alpha. Okay, this is the thing, we need to get the value of alpha. That is the intention of this one. Here we can cancel 2 and 2 will get cancelled, L and L will get cancelled. So what will come here? EQ will come. What will come on the right side? ml plus ml. So what will come? 2 ml into alpha. Alpha equal to QE divided by 2 ml is the right answer. If the value of charge is given and the value of electric field is given, the value of M is given, value of L is given, the total distance is 1 meter. In this example I have given L, 2L will be equal to 1 meter. So L will be equal to how much? 0.5. So I can substitute in this given question. It is given L will be equal to 1 by 2 because 2L is 1 meter. 2L is a distance. So half of this L is 1 meter. If I substitute here, my answer will be Q equal to 2m into 1 by 2. So 2 get cancelled. Answer is QE divided by m in this case. This is I just taken an example and I have assumed certain values, and in the real questions you may get different values for different parameters. But what I am trying to given to you here, it is like the torque equations, whatever you have learned in electrostatics, it is called PE sin theta, which you can able to connect with any other torque equations you have learned, depends upon the situation. Here you have to learn torque is equal to I alpha concept. So torque is equal to I alpha because here question is asking about alpha. So we need to connect your second year electrostatics with the first year rotational motion. That's what we are always recommending the students to learn the first year topics along with your second year topic, because that is quite important. In your Neet examination, 50% of questions from Neet or J or any other entrance whatever you are writing, 50% of your questions from second year and 50% of your questions from first year topic also. So torque equal to here PE sin theta, and which is equal to I alpha. So we have solved this example. Okay, similarly there are questions are also coming, also chances are asked to questions normally from the area of oscillations, from the area of magnetism. So there are a lot of examples which we can connect with respect to this rotational motions we have connected here. Same way they will connect with this force into perpendicular distance concept also. Let's see another examples from with respect to your oscillation chapter. Okay, now we have connected the equations from with respect to your rotational motion. Now we are going to connect with oscillations. Let's see the question. Electric fields are like this. Dipole is placed, minus q will be here, and this is plus q. Okay, so angle between P and Q, initial angle between P and E will be equal to 0 degree. Okay, when we give a small disturbance, when we give a small disturbance, in bracket theta is small. If theta is small, then the question is, the main highlight of the question is, then at what time period, the dipole oscillate, which means what I called when the angle between P and E equal to 0 degree, that is called stable equilibrium. So in the stable equilibrium position, sir, if I am going to change this dipole, I just tilted like this. So what will happen? There are two forces will happen, right? F is equal to QE like this, and F is equal to QE like this. F is equal to minus QE, right? So F is equal to plus QE left. So initially it is like this. Now if I giving a disturbance like this, so as it is stable equilibrium, because of the two forces, it will come back to the original position, which means that what mean this is like this. If I'm giving some force, if I'm giving some small disturbance and I've kept it like this, because of the electric field, QE force here, QE force here. So what will happen? It will just oscillate like this, oscillate, and come back to the initial position. So it is just oscillating like this, and the speed will be reduces and it will come back to the original position. What is the time period of oscillation? Question is good, right? Yes, question is good. Question is a nice one. So at what speed, at what at what time period this will oscillate? That is a question. Okay, so of course we know this is related to torque. So torque will be equal to, our equation is PE sine theta. In the given question it is given theta is very small. So in physics we have a property, if theta is very small, sine theta is equal to theta in physics. Okay, and in oscillation there is one property will be there. In oscillation, force is directly proportional to minus x. This is a concept in oscillation. F is equal to kx, you have learned, right? So similarly there in oscillation there is one concept, force is proportional to minus x. Force in linear motion, corresponding in rotational motion, what is called torque. Instead of x, what is coming in rotational motion? Angle theta. So torque is proportional to minus theta. Similarly, acceleration A equal to minus omega square x, alpha will be equal to minus omega square theta. These things we need will be here. These are the things which we have there in our oscillation. We are going to use it will be here. So torque is equal to PE theta. Torque in case of oscillation, torque is proportional to minus theta, force is proportional to minus x. So torque will be equal to PE of minus theta. As it is an oscillations, I can put it as what is called I can put it as torque is equal to I alpha. I told I can equate torque with any of the conditions, which is equal to PE into minus theta. So PE minus theta will be here. What is called alpha? I already written alpha will be there, right? Because we need to get time period. So if once we get omega, omega is equal to 2 pi divided by t. So what is alpha? Alpha is given minus omega square theta, which is equal to PE into minus theta. Theta cancel, minus cancels. So omega square equal to PE divided by I. Omega equal to root of PE by I. What is omega? Omega is called 2 pi divided by time period, which is equal to root of PE by I. So we need to find out a time period from this one. What is time period? What is time period will come? T is equal to, we can cross multiply, right? T is equal to 2 pi into root of I divided by PE. This is a very important relation. This is a very important relation. Time period, the equation of a time period with the moment of inertia and dipole moment and electric field. T equal to 2 pi into root of I by PE. Remember this equations, put it in a box. Normally this is already coming as a lot of time for entrance examinations. They will give you the value. They have directly asked us a formula. They have given you, they will ask you the formula as such it is, or they will give you the value and you have to substitute, you have to find the value. So this formula we have derived it from a dipole which is initially placed in a stable equilibrium. If you have given a small disturbance also, it will come back, it will return back to the original positions, where we are going to find out. Return back to the original position means with a certain vibrations, it will vibrate and it will come back to the original positions. So in that case, the time period of oscillations what we have calculated here. Okay, this is all about the torque. Okay, thank you and thanks for watching, and if you have any doubts, come back to us as usual. Okay, bye.